Here are the work solutions for the 2012 option test. The first problem, use L'Hopital's rule to find that limit. Remember, L'Hopital's rule can be used in three situations. When you have a 0 over 0, or a 0 over infinity case, or 0 times infinity. All right, so let's see which type of case this particular example is. The first step is to sub in 0 into the expression e to the x minus 1 minus x cosine x over sine squared x. All right, subbing in 0 for x, we'd have e to the 0 minus 1 minus 0 times the cosine of 0 all over sine squared. That's 0. Well, e to the 0 is 1 minus 1. 0 times cosine of 0 is going to give us a 0. And the sine of 0 is 0, so 0 squared is 0. The result is 0 over 0. So we know that L'Hopital can be used to evaluate this limit. All right, the next step in L'Hopital is to take the derivative of the numerator and the derivative of the denominator. So the derivative of the numerator, the derivative of b to the x is e to the x. Derivative of 1 is 0. And then we'll go minus the derivative of x cosine x. Well, x cosine x is a product, so here goes the product rule. First is x, derivative of second is negative sine of x, plus the second is cosine of x, multiplied by the derivative of the first, which is 1. And that's all over the derivative of the denominator. Well, sine squared x is the same as sine of x quantity squared. So we use the chain rule by moving the power down front. So it's 2 sine x times the derivative of the inside, or the parentheses. Well, the derivative of sine is cosine. All right, now that we have that result, we will now try to sub in 0 and see what our result is on this limit. So e to the 0, again, is 1 minus quantity. X is 0 times negative sine of x. It doesn't matter because we're multiplying by 0, plus the cosine of 0, all over 2 times the sine of 0, which is 0, times the cosine of 0, which is 1. Well, on the top, in the numerator, the cosine of 0 is 1. So again, we're going to have 1 minus 1, which is 0, over 0. So L'Hopital, after its application, we still have a 0 over 0 case. So what we do is take the derivative one more time. So going back to our last result, which I'm boxing, we want to take the derivative of that. So e to the x, the derivative is e to the x, is e to the x, minus quantity product. Well, the product rule goes into effect again. First, which is x, derivative of the second, the derivative of negative sine of x would be negative cosine x, plus the second, which is negative sine x, times the derivative of the first, which is 1. And now the derivative of cosine x on the end will give us negative sine of x. So the numerator is done. Now let's do the denominator. Another product, so I'm going to say 2 sine x is the first factor. So it goes product rule, first 2 sine x. Derivative of the second, cosine x is negative sine x. So I'll put sine x, stick the negative sign out front. The product rule plus the second, which is cosine x, times the derivative of the first. Well, the derivative of 2 sine of x would be 2 cosine x. All right, now we have a lot of zeros to sub in. Well, here goes. E to the 0 is 1 minus 0 times negative cosine of x. Again, it's going to be 0. Negative sine of 0 is 0. And then negative sine of 0 is 0. So all the parentheses give us nothing but zeros. Denominator, subbing in 0, negative 2 times the sine of 0 times the sine of 0 is 0. But the second term, cosine of 0 is 1. So we have 1 times 2 times 1, which is 2. So we end up with final result of 1/2. So after applying L'Hopital's rule twice to evaluate the limit, we find that the limit value is 1/2. 6 marks. Yay!